Lesson 9.4 is simulations. So we've been talking about theology. We've been talking about theoretical and experimental probability and the difference between what that is. And so theoretical is in theory, how often something would happen, where experimental is actually doing the experiment. Simulations are the way that we actually can do an experiment without actually doing the activity. So one of the examples we'll talk about later on is talking about chances of rain. Well, we can't actually know the chances of rain. We can't reenact that. But if it's a 60% chance of rain, we can use marbles to reenact that to find the probability. So it's making something that's not tangible so that we can do an experiment. So a simulation is an experiment that is designed to model the action in a given situation. For example, you use a random number generator to simulate rolling a number cube. Simulations often use models to act out an event that would be impractical to perform. 1A, a cereal company is placing one of 8 different trading cards in its boxes of cereal. If each card is equally likely to appear in a box of cereal, describe a model that could be used to simulate the cards you would find in 15 boxes of cereal. So again, this is coming up with a tangible experiment. So lots of different things you can do. The book suggests you toss 3 coins. When you toss 3 coins, you can get heads. So that would represent trading card 1. You could get heads, tails. That would represent trading card 2. You could get heads, tails, heads. That would represent trading card 3. You could get heads, tails, tails. That would represent trading card 4. You could get tail, tail. That's trading card 5. Tail, head. Trading card 6. Tail, head, tail. Trading card 7. And tail, head, which is trading card 8. So you can see by tossing the 3 coins and having this key, it would be easier to go, oh, the first box of cereal would have trading card 5. The second box of cereal would have trading card 6, and so on. So you would just do the experiment. This is one idea. You might have your own very creative way, and we'll talk more about that in class. 2A, every student who volunteers at the concession stands during baseball games will receive a free school t-shirt. The school t-shirts come in 3 different designs. Design a simulation that could be used to model this situation. Use your simulation to find how many times a student must volunteer in order to get all 3 shirts, is what that's supposed to say, not all 2. So, in my mind, the simulation that just stood out the most when I read this is a spinner. So if you look at this spinner, I spin it once, and I get the red t-shirt. So volunteer the first day, and I get the red t-shirt. Spin it again. Second time I volunteer, I get the green shirt. Ooh, the third time I volunteer, I get the blue shirt. So I only have to volunteer 3 times to get all 3 shirts. Now, somebody else might go right now and they get green first time, red second time, red third time, red fourth time, green 5th time, and finally blue the 6th time. So they have to volunteer 6 times to get all 3 t-shirt designs. So that's the thing with probability, is you never know what's going to happen. Again, I came up with the spinner idea. You may have had something else in your mind when you heard 3 different options. And that's what this is about, whatever works for you mathematically. Mr. Jones must wear a dress shirt and tie to work. Each day he picks one of his 6 ties at random. Design a simulation that could be used to model this situation. Use your simulation to find how many days Mr. Jones must work in order to wear all of his ties. So again, this is just like the spinner. Well, what happens for one person may not happen for the other. So we're just going to see, we're going to go day 1, day 2, 3. Hopefully he only has to go 6 days, but we'll see. So the first day he works, he wears tie number 3. Put it in a different color. Second day he works, he wears tie 4. Third day he works, he wears tie number 2. Fourth day he works, he wears tie 4 again. Fifth day he works, he wears tie 3 again. Sixth day he wears tie 6. So at this point we know we're going to have to go more. Seventh day he wears tie 5. So the only one we're waiting on is tie 1 at this point. Eighth day he works, he wears tie 3. Ninth day he works, he wears tie 5. Tenth day he works, he wears tie 2 again. 11th day he works, he wears tie 6. 12th day he works, he wears tie 2. Ooh, and on the 13th day he wears tie 1. So at this point he has worn all his ties. So he has 6 ties, but it took him 13 days to wear all of them. Again, there might be somebody who it takes 6 days. Just depends on the probability and how the dice rolls, literally. Their simulations can also be used to model events in which the outcomes are not equally likely. So 3A, there's a 60% chance of rain for each of the next 2 days. Describe a method you could use to find the experimental probability of having rain on both of the next 2 days. So the book's option, which I thought was a really good one, is they say put 3 red and 2 blue marbles in a bag. And red, which is would be 3/5 of the marbles, is equal to 60%. So that would equal rain. And the blue would equal to 40% of no rain. And so every time you draw, it would represent if it had rained or if it did not rain. So again, all of these are just ideas. This isn't something crazy hard that you have a bunch on the test of. It's just getting your brains thinking of ways that you could simulate and determine if the simulation was a correct simulation or a false simulation of the probability.